In the following, I'm going to show you how to navigate the ExploreDesktop app. Start the app and wait for it to open up. Of course, installing the app differs per operating system. However, you can simply have a look at our wiki page to see how it is being done. After opening the app, you can connect to your device. Make sure that it is advertising, which is shown by blinking quickly with the blue LED. After typing in the device name, press connect and you should be connected to your device. You will then move on to the settings page. Here you can see how many channels you have connected. Right now I'm using an 8-channel device, but you can also select a 16 or 32 channel device. You can enable or disable channels to say whether they should record or not. You can of course change your name by typing in or selecting from the drop-down list. Apply. You can of course import or export settings simply by going to Export Device Settings, select the name and save. Importing is similarly, go to Import Device Settings, press the demo or something else to see that importing the settings is very easy. You can also format the memory by pressing Format. This will wipe the memory. Be sure you want to do this. Is formatted. If you've made some changes, such as enabling or disabling channels or changing the sampling rate and would like to revert these, simply click on Restore Default Settings. This will soft reset the device back to the initial settings, where all the channels are activated and the sampling rate is being put to 250 Hz. To move on, we can go to the Impedance tab. The impedance measuring step is a crucial step in any EEG experiment. Select what electrode format you have. Right now I have dry electrodes, and start by measuring the impedances. In the dry setup, we won't have color coding, but we aim for impedances below 300 kilo ohm. In the wet electrode setup, you will see that these black dots change in color according to how low the impedance is. There we aim for around 10,000 ohms. If you have selected a valid 1020 montage name for every channel, you can also select the EEG montage and you can see the 1020 montage setup. Moving on, we can go to the Visualization tab. In the Visualization tab, you will be first asked about the visualization settings, where you can select baseline correction, which will correct every signal we receive to a certain baseline, an average, and a notch filter to filter out power line noise. You can also select a low cutoff and a high cutoff frequency to filter out any noise that might come from higher or very low frequencies, even though those are difficult to detect. Press OK, and we can see that the data is being visualized. In this tab, we can also change the y-axis scaling, as well as the time window shown in one sweep. Besides that, we can also push the data stream to LSL, which allows us to integrate multiple data streams, such as from a Unity game that sets markers, from a Python code that runs in the background, a Mentalab code, but also the raw data file we have here. Pressing this will ask you whether you want to share or not. We can also apply visual filters. Note that these do not apply to the raw data file which we will record, by changing and going back to the visualization settings. This visualization tab also comes with the orientation. Here you can see an accelerometer, a gyroscope and a magnetometer. When I move my head, you can see that these 9 axes record any data you might need. Lastly, we also have the foyer space, where we can easily inspect what frequency bands are being used in the recording. Let's try to use some alpha. As we can see, there was a small peak at the alpha frequency band. Now, visualization is great, but what we want to do is record data. To record data, click on this button and select the settings you want. We support open file formats such as CSV and PDF, which is a higher sampling rate of the EDF file. If you want, you can also record in binary file format on the device locally. However, this will not record the markers set virtually, which I will show you soon. Select the folder and name of the file. You can browse, you can change the file name and select the recording time. If you don't know how long your experiment will last, because it may differ between participants, select a long recording time such as 3600 seconds and press OK. Now the recording is in progress. You can send markers virtually by typing in a name and setting it. You can also do this on the device by pressing the button. Finally, to stop the recording, simply press on it or wait until it has finished. There are a few tools I haven't talked about yet, which are data repair, converting a binary file to an EDF or CSV file, or exporting to an EEG lab dataset. The data repair uses a binary file, which is a file which has been recorded locally on the device, as well as a CSV or EDF file, which has been recorded on your computer, to repair the CSV file if there has been some data loss. The binary file has recorded everything that has happened and there won't be any loss, but it could be that because of a bad Bluetooth connection, the device, the end device, could not record everything. What will happen is that the binary file will be used to stitch back together the CSV file. The CSV file is differing in the binary file in that it records also the virtual markers. When you have an ongoing recording, you can also inspect the data. Here, it will show you the amplitudes of each channel and at what time. Refreshing this will continue to add the timestamps. Lastly, we can convert a binary file that is a locally recorded file to a CSV or EDF file. Select the file to convert and the output format, where to export the file, and press OK. With that, I thank you for your attention. If you have any question, consult the wiki at wiki.mentalab.com or send us an email, either at support@mentalab.com or reach out to us at contact@mentalab.com.